Flash 7, when it came out, it tightened down the restrictions a little bit, and so that foo.example.com could only talk to foo.example, or could only, scripts that came down could only talk to foo.example.com. It leads to cases of frustrated admins, which when you search on Google Groups for Flash 7 cross-domain restrictions, you get a response like this. In my case, I simply use star rather than star.domain.tld. Also, another thing with that is that the cross-domain policy files are no longer restricted to just the default one. It can be anything, so you need to look around to check for that. It's got another great acronym, FJAX. And with the proper cross-domain.xml setup, you can read and write arbitrarily whatever they specify. Why are they interested? Everybody remembers our login, which when you specified ++ in there, anybody could log in. Here's the new version for web apps. Cross-domain, or allow access from domain equals star, which is really surprising how much you'd see that. Because the web development community is really they really want this functionality. This is something to look out for in the coming years, and this is really, like Alex has been saying, really going to increase the XSRF attack surface. Like I said, you would be surprised as to where this comes up, seeing allow access from star. You can take a guess as to which one in here would be the most embarrassing. If they had Flash as cross-domain star, you'd probably be right. So let's take a look at the frameworks then.
So, I mean, the bottom line there is, if you go back to your company and they have cross-domain.xml and they say allow from star, the statement you are making is, I don't care if people authenticate as other people on my web application. That's what that means. So you can use it in some situations. If your web service is giving people temperatures, right, or you're like Craigslist and you're just freely giving out information, it's fine. But in any situation where people have to authenticate, it's bad. I just want to apologize to Johnny Long for this. I know we stole all his Google hacking techniques to be able to do this. I'm sorry, Johnny. Thank you. Okay, nobody was at BlackHat last year? No? Okay, so AWS framework. So we talked about a lot of security bugs. Some of them may or may not be better or worse with certain frameworks. So we looked at 3 of them, and we tested them using the example demo applications that they give out. The 3 we looked at are Java Direct Web Remoting, Microsoft Atlas, and Google Web Toolkit to try to get a nice broad view of different platforms and different types of Ajax. Direct Web Remoting is very interesting. Obviously, it's for Java. And the really cool thing about it is you don't have to rewrite your application to use it. If you have methods in a Java enterprise container, all I have to do is install the DWR classes, and then I put in an XML file. I say, I want to expose these methods to the internet. So maybe those methods are transfer money and login and stuff like that, and I put that in the XML file. And without even recompiling or changing the code in my Java app, it magically goes in and wraps those functions and exposes them, and it generates JavaScript to automatically expose it to everybody. And it generates that JavaScript object that acts as a proxy. This is kind of your basic proxy-based Ajax, right? And it's nice and easy. It's pretty cool. But because it is a proxy, the proxy object itself, since it has no understanding of where you are in the state of the program, right? It's supposed to be just there for people to call. It has to know about all of the different functions you expose. And so as an example, there's 2 ways with DWR to find out all these functions. One is they generate these files that are big HTML documentation files for all the methods. And in all of the sites we looked at, these files were still on. So if anybody here knows Rainforest Puppy or any of those guys and they have control over what goes in the NICTO database, this is definitely something, right? Because if somebody has Java DWR, they might have a thing that says, this is all the functionality on my server. Please attack me. But the other way that's pretty simple, even if they turn that off, is that, like I said, they have a JavaScript file that comes down and that understands all the different functions and what arguments they take. And this situation is a very, very simple one. Cross-site scripting. The downstream traffic in direct web remoting is JavaScript. It's parsed and it's placed into a DOM. There doesn't seem to be any client or server filtering. The bottom line is this is a real screenshot. I do not rely on DWR for cross-site scripting filtering. Cross-site request forgery. Upstreams are gets and HTML form posts, like we said. gets and posts within the HTML, name value pair is very easily faked, either by doing like an image or script tag for a get, or doing an iframe for a post. Sometimes there is this call ID info that's thrown in there that looks like, it doesn't look like it's truly like cryptographically random, but it's probably random enough to make an XSRF attack not feasible. The downstream is available JavaScript. The bottom line is, without any custom protections that you build into your app yourself, if you use WWR, you're probably vulnerable to XSRF. Although the call ID prediction stuff needs research. It does not require the XML HTTP object, even though it's an Ajax framework. And so you lose all the protections of doing something like JSON with an XML HTTP that makes it difficult to falsify. Okay, Microsoft Atlas. Microsoft came out with their own Ajax framework. Obviously, it integrates on top of ASP.NET 2.0. This is not a proxy framework. This is more of a client-side rendering framework. The idea here is that you build something out in your IDE that looks like a file that ASP.NET would render and would create. So maybe I have like I have a big table, and I have like an ASP.NET table object, and then I just change the code a little bit, and automatically turns that into an Ajax table, right? So it's not like a proxy framework where it exposes all of these C# functions. Like, it's not like a SOAP interface. It's more like something that just changes the rendering of specific components. As a result, method discovery is a little bit more tricky, but not that tricky. And just like DWR, the methods are sent down in JavaScript and pretty easily parsed out and easy to read. Don't take this as a direct of any of these that we're directly criticizing them. I should have said at the beginning, I'm just trying to lay out that maybe you don't want to rely on these frameworks to give you lots of protections. You still need to think about security. Cross-site scripting, the downstream JSON, or JSON-like functionality, and proper JavaScript. There is this thing called ASP.NET validate request, which seems to be perfectly fine working with Atlas, and it's turned on by default in all their demos. And so that's good protection. It's not perfect. I wouldn't rely on any kind of global protection for everything, but at least in all of the demos we looked at, the flaws were fixed. So that's smart. There's probably cross-site scripting would be possible, but this definitely improves the situation. XSRF are upstream JSON-ish or actual JSON by XML HTTP request. Those cannot be faked by using an iframe. There are some situations where there's single gets. There is no entropic or cryptographic information added to request by Atlas. As a result, functions that take gets and change state, which is tough to predict, right? This isn't like a procedure call thing. This is if you use a table versus you use a button versus you use a drop-down box, you get different functionality, right? And it's not really predictable. But in the situations, things that are provided by gets are probably able to be attacked. The posts are much more difficult to attack and probably not as much. But this one's difficult to predict because in the different demos, we saw totally different types of communication. Google Web Toolkit. Google has their own Ajax framework, which we couldn't find it actually running on any of their big sites. I don't know if they use it themselves that much, but they have this Ajax framework. It's kind of like Atlas in that it's not a proxy thing. It's meant for client-side rendering. And the idea here is you write a Java application that looks like what you want to be in the browser, and then they have their magic in their magic pixie dust, and the magic pixie dust turns the Java code into JavaScript that runs and does the Ajax stuff. It's pretty cool. Does require you to totally rewrite your web application, unlike DWR, but the results look pretty cool. The method discovery is much more complicated. If you watch the traffic from Google Web Toolkit, you see absolutely the most ugly JavaScript code you've ever seen, which pretty much means it's almost certainly intentional obfuscation. I don't think they did this because they wanted to protect against method discovery and parameter tampering. I think they did it because they wanted to protect their intellectual property. But you get things like this, which is just completely unreadable to anything but an actual JavaScript compiler. It does turn out that there are a handful of functions in a thing called a .cache.html file, functions that have underscores in them, and those underscore functions are customized per application. And so it's quite possible by getting those underscore functions that you could replicate a list of all of the functionality exposed by methods, but it would be pretty difficult. XSS is difficult to test and difficult to attack because they use all this crazy stuff on the wire. They don't use JSON. It's amazing. Google is using non-standard stuff. for doing their stuff, which actually in this situation makes things a lot more difficult to attack. But doing fuzzing and playing with a bunch of different characters didn't seem to do any harm. Those characters just seem to come through encoded properly. So XSS might be possible, but it seems kind of unlikely. And even if there was XSS, might be a little bit complicated by the fact that they use such weird encoding formats. As far as XSRF, they use a custom upstream serialization, like the one you see here, which has obviously things like Java classes enabled in there and a bunch of unprintable characters. This uses XML HTTP request, and so therefore we're not able to fake it using an iframe or using a get. As a result, cross-site request forgery seems unlikely. This definitely needs more research to see if there's any places in which the Google Web Toolkit will use a simple get instead of a post to do any state changes. But in the little bit of testing we did, we couldn't find that. So what's the conclusion of our little survey of frameworks? We also looked at a bunch more that we didn't write up, but little ones. I mean, there's dozens and dozens and dozens of Ajax frameworks. None of the frameworks talk a lot about security. They don't talk about it in their documentation. They don't talk about it in their comments. It's not something they advertise. Atlas comes with this cross-site scripting protection that they get from .NET. And that was the only situation where we saw like an obvious security precaution. Obviously, Google is probably doing something, some kind of input filtering or escaping mechanism server side. To protect against XSS or XSRF on all of these or in any framework, it's up to you, the developer, or the security person who's checking it, to understand the traffic. You can't make any really global statements just from looking at the traffic. You have to understand how that functions. And it's hard to make global statements on the frameworks because they use gets here and posts here, and maybe they have JavaScript coming down here, and maybe they don't here, and it's often just dependent on the design of the app. And just overall, you never rely on other people's code. None of these things are they should all be obvious, but the real problem here is that these frameworks make it really easy to write web applications, and so you end up with an abstraction layer between the developer and the actual wire. And every time that happens, you end up with people that don't understand what's going on in the wire. They don't understand things like SSS and XSRF. So we'll talk about some future trends. It's kind of like we are moving to a web-based OS, like almost at somebody's business model for world domination. A lot of sites now have codes running from all kinds of places. People have things called plugins. People have things called gadgets. You can download even true for Win32 software that runs on your desktop, like Google Desktop has plugins that are written in JavaScript, right? So they're running on your machine, but they're running within an IE, within a IE scripting host. WindowsLive.com from Microsoft has all this plugin architecture that people can write all these plugins like, hey, don't you want to see all your friends' Xbox gamer cards and stuff like that? RSS feeds. Anybody here use an RSS aggregator that happens to be a web application? You know what you're doing when you do that, right? You're saying, I trust this aggregator. Maybe for you, sir, it's probably the Google desktop customized homepage. And you're saying, I trust that they are doing filtering on all this RSS when it comes in to make sure that there's no script in there that then runs within my context with my cookie. This is all complicated by the fact that Microsoft, Google, and Yahoo, the big three of the web, all use these single sign-on systems that have extraordinarily long cookies and that let you sign into everything from your bank account to checking your mail to looking at your RSS reader, right? Which obviously stealing a cookie with an RSS feed might be more important than just getting somebody's RSS feeds, right? You might be able to get something very important to them. So I recommend you go check out these desktop managers and play around with them and think about, do you trust all the code running in them? JavaScript has no internal security model. It has a security model enforced upon it by IE or Firefox. It doesn't have a security model like Java does where you say this function can only